So for this session, thank you folks for joining. For this session, we'll be talking about how to get your Kubernetes deployments production grade and production ready in a multi-cluster world with NGINX Ingress Controller. With that, we'll kick things off, and we'll also have a demo halfway through the presentation as well. So before we kind of jump into the product set and what Kubernetes and NGINX Ingress Controller is all about, as many folks know, in today's world, there's a very easy way to tell that a company isn't using modern apps, development technologies. It's easy. Their customers are quick to complain on social media. They complain when they can't stream the latest binge-worthy release or access your online banking or make a purchase because the card is timing out. But with new modern application architectures, as you guys can see, adopting microservices is challenging both because they can be difficult to monitor and because successful adoption has significant impact on the organization's culture and systems. And changing your application architecture, updating your CI/CD pipelines, increasing complexity by deploying large numbers of services that communicate over the network, it's inherently risky and can seem quite daunting at times. On the other hand, the benefits of using microservices, including containers and Kubernetes, include greater resilience in the face of traffic spikes, for example, increased and more rapid development, and ongoing experimentation in search of optimal end user experience. Nonetheless, it seems the challenge and risks are outweighed by the benefits. But how can you make microservices and Kubernetes journey for yourself less daunting? One of the things that NGINX and our team has learned is that it's all about the architecture. As many folks over the course of this morning and today have mentioned, it's not just necessarily about the F5 product portfolio, but also the ecosystem of partners that make that modern application architecture work. I like to explain the core difference between monolithic and microservice architectures by using an analogy of a string of holiday lights. When a bulb goes out on an older style strand, the entire strand used to go dark. If you can't replace the bulb, the only thing worth decorating with that strand is the inside of your garbage can. This old style of lights is like a monolithic app, which also has tightly coupled components and falls if one component breaks. But the lighting industry, like us in the software industry, detected this pain point. When a bulb breaks on a modern strand of lights, the others keep shining bright, just as a well-designed microservices app keeps working even when a service instance goes down. Containers are a popular choice in microservices and architectures because they're ideally suited for building an application using smaller, discrete components, as most of you folks know. They're lightweight, portable, easy to scale, and Kubernetes is the de facto standard for container orchestration today. But there's still a significant number of challenges around making Kubernetes production ready. A couple of years ago, many companies started their microservices and Kubernetes journey, and soon enough, many of these same organizations realized though the concepts of microservices were effective, to shift their entire development philosophy, culture, and associated tooling was quite cumbersome and quite a heavy lift. With that, you can see how quickly companies around the world have gone from testing microservices and Kubernetes to now pushing those workloads into production today. The net is microservices and Kubernetes isn't going anywhere, as most of you folks on this call know, and will continue to grow. So what can you and the organizations around the world do to stay ahead of this curve? In terms of overall challenges, complexity, as many of the folks on this call have mentioned over today, security, cultural development shift internally, and observability are some of the primary concerns, keeping most folks that we talk to up at night. Not to mention development is a significant challenge with regard to scale, speed, and quality, not to mention the tool or language selection or the ecosystem of partners and tooling you might be using. Modern apps require different tools, and we've seen their use grow steadily over the years we run the survey. In support of microservices management, we see investment in commercial and open source container orchestrators, plus API management, as well as diversifying public cloud usage as they continue to increase, along with ongoing migration to best-of-breed software load balancers, API gateways, and with Kubernetes, ingress controllers. Taking it a step further, I think one of the things that we've recognized and understood as an organization all up at F5 is that most of our customers and organizations are now looking at how to leverage as much open source tooling that's available to them that's considered best of breed how can we prevent vendor lock-in as we think about diversifying our cloud portfolio, as well as how do we not lock ourselves into native cloud provider tooling as well. And that's where NGINX has shined over the years, right? Is we started out as a web server and one of the most widely used web servers in the world. And one of the reasons why organizations and the community have fallen in love with NGINX is because of the way NGINX can be deployed agnostically to any deployment model of your choosing that best fits your business requirements. With Kubernetes, with the growing of Kubernetes and microservices, as well as the hybridization of cloud deployments and on-prem deployments as well, what we're finding is that most organizations are looking to rein in tool sprawl without introducing additional complexity and overhead for their development teams, while making sure that they have consistent tooling across these developments, as well as making sure that they're making the most use of their investments. And I think that's one of the most interesting use cases for NGINX is most organizations know NGINX to be the best and highest performing lightweight web server and reverse proxy and load balancer and API gateway that's out there. And that's typically how they're starting their journey, where they're deploying NGINX to host those web apps. Then they're looking at deploying some sort of reverse proxy or load balancer as the front end, and being able to extend the functionality of NGINX with consistent tooling that their development teams are familiar with is a huge value add. So when you're talking about modern apps and thinking about pushing your microservices as well as your Kubernetes deployments into production, where do you start and how does one define a modern app? So Dylan, tell us about what our vision has been for modern apps and some of the more important components to make Kubernetes deployments production ready.
Yeah, it's an interesting landscape. I guess one of the things I'd like to point out in this slide, or at least I'd like the audience to take away from this slide, is this is a micro view into what is ostensibly the CNCF interactive landscape. And if anybody's ever viewed that chart on the CNCF website, it is astronomical, the amount of potential tools or solutions you can slot into any one of these categories. So as a solutions architect, part of my role is to go ahead and part of the reason why I have a 24U rack that's entirely full in my garage is to prototype all of these pieces to see what am I going to use for a code repo? How does that work? What am I going to use for CI, whether that's Actions or Jenkins? What am I going to use for building the application? And where we come in as far as the Kubernetes journey is concerned is we act as the ingress controller in this case, which for those that are unfamiliar with an ingress controller, it basically allows us to access the underlying workload and the application that's sitting inside the Kubernetes cluster. And we've learned as part of this journey, as you can kind of see in the slide, that it takes a village to raise an application. We can't do it on our own. So part of what we've done is we've worked through this, and where we bring our area of expertise, we also have fostered fantastic partnerships with folks like Armory and Pulumi and Red Hat and Rancher to be able to fit into those ecosystems and also play across the different platform targets. But the big takeaway here is it's a complex endeavor to be able to get through building one of these architectures, and there's so many tools out there. Quite often it can be daunting to try to find the ones that deliver on their promises. So.
That's right. Thanks, Dylan. Mm-hmm. And I think as we're looking at this slide, when we're talking to organizations and our customers, this is more or less a real life example of how they're composing their modern app architecture and all the different pieces and components that go into managing, scaling, having visibility, having security layered at each of these components, where the ecosystem of partners and the ecosystem of tooling that goes into deploying Kubernetes is quite vast, but it doesn't necessarily have to be that hard, as Dylan will show you in the demo here in a couple minutes. So Again, as Zubin touched on earlier in our presentation, while many people know NGINX as the highest performant web server, reverse proxy, or even load balancer and ingress controller, what we've achieved in almost the last 2 years since F5 acquired us, and particularly during COVID, has really proven that NGINX technology continues to grow beyond these capabilities and support applications as they evolve from simple web apps to more complex distributed microservices. And I think a lot of folks on this call earlier today were asking about, well, where does NGINX shine? And I think that's one of the biggest advantages of NGINX, and one of the reasons why the community and a lot of our customer base appreciate how verse and how much of a Swiss Army knife NGINX can be. At the core of it, it is one of the most lightweight, highest performant traffic management solutions out there. And organizations deploy us for web serving, for API gateway functionality, reverse proxying. But at the end of the day, and at the core of all of that functionality, it's really the ability to have sophisticated, very, very fast, lightweight, agnostic traffic management capabilities, and being able to extend the NGINX functionality and their consumption across different use cases along the data path. As it relates to F5 and Volterra, we're just extending the data plane and control plane capabilities to give customers and organizations an easier path to managing and reining in a lot of the tool sprawl that's happening with the deployment of microservices and the management of these microservices across these different application teams. And then, of course, with us, making sure that we're working within the ecosystem to give organizations as much choice to be able to deploy the technologies and the tooling that doesn't just make sense for those technology and application development teams, but also that makes sense for the investments that they've made over the years, as well as based on the business requirements that are coming down. So one of the use cases, as I mentioned before, with NGINX open source and NGINX Plus is the Ingress controller. There are 3 NGINX Ingress controllers that are available out in the wild today. And NGINX Ingress controller is the most widely used and most popular ingress controller for Kubernetes. And to kind of go back to the genesis of Kubernetes and why the Kubernetes community adopted NGINX was because of how lightweight and how lightning fast we were from a traffic management standpoint, and how we were focused on how modern apps were being built. Fast forward to today, there's obviously a number of different ingress controllers out there, just as you've become familiar with the number of different load balancers that are out there as well. But the most important piece of this, and going back to the 3 NGINX Ingress controllers that are available, there's one that's maintained by the Kubernetes community, which we continue to contribute and help maintain. And there's 2 others in the NGINX open source and NGINX Plus Ingress controller that's maintained and managed by the NGINX Inc. org and by our PM organization. The primary differences between the community NGINX Ingress versus the NGINX Ingress controllers that we maintain is our development philosophy and our focus on stability. And that becomes very, very important as organizations are looking to start or are already moving a lot of these container workloads and Kubernetes workloads into production. The ability to have stable releases and stable deployments of your ingress controller for sophisticated traffic management, to be able to layer on security at the front door of the entry point of your Kubernetes pods. And then, of course, being able to have extensible observability across these Kubernetes deployments and within your containers is top of mind for a lot of organizations. So with the NGINX Ingress controller, we're combining trusted NGINX software load balancing that most organizations are deploying NGINX across their infrastructure for a number of different use cases that we touched on today, and being able to ensure that applications in your Kubernetes cluster are going to be delivered reliably, securely, and at high velocity. The second piece of that is built-in security. So being able to, additionally optimize SSL and TLS termination performance with configurable encryption, including wildcard certificates and securing your applications using JWT authentication and SSO. And then again, as I mentioned, being able to deploy a WAF at the point of ingress or anywhere in the clusters with NGINX App Protect, and being able to extend those WAF capabilities outside of your ingress onto your load balancer and at the edge as well. Getting traffic insights. I mean, I think this is, as more and more organizations are deploying Kubernetes into production, this has become, one of the top three asks and challenges for a lot of our customer base is how do we get and improve visibility in Kubernetes with real-time stats about the application traffic flow and historical views enabled by detailed logging, whether that's native to NGINX or with third-party tools like Grafana and Prometheus, as well as Datadog and some of the more popular APM tools. And then lastly, consistent tooling for scalability and leveraging the core of what NGINX is really good at. Again, being really lightweight, performant, being able to be highly portable, being able to take it across any cloud provider for any of the number of use cases that you might be familiar or deploying NGINX for, along with the power of the Kubernetes ecosystem. So with that, Dylan's going to be showing a fairly quick demo of being able to deploy the NGINX Plus Ingress Controller on Rancher. To kind of give you a high-level overview of Rancher, Rancher today has become known as one of the most widely used open source Kubernetes management platforms out there. As you've seen kind of across our slides, NGINX has always thought about the customer experience first and ensured that interoperability has been top of mind from a product development standpoint to ensure that, we understand that organizations' technology strategy as well as their business requirements are constantly changing, constantly shifting. And the need to be able to not have NGINX lock you into a particular architecture or a particular deployment model has always been one of our most important and core ethos as we think about building out our product. With Rancher, they share a very similar sentiment where they make it very, very easy for organizations to deploy Kubernetes into production, regardless of where those apps are living. Whether you're deploying it on the Rancher platform or deploying it on AKS or EKS or GKE, Rancher provides an easy UI for you to be able to ingest a lot of these managed Kubernetes deployments and have a single UI to be able to manage across different cloud providers. And then, of course, be able to extend the NGINX Ingress Controller functionality regardless of where your Kubernetes apps are living. So with that, Dylan, I'll turn things over to you.
All right, so I want to start by setting the stage. Like Allen was talking about, one of our key partners has been Rancher, and now by proxy, SUSE. And one of the things we value as part of that partnership is this concept of open, right? So we're not going to, rather than trying to railroad you into a specific solution or a type of solution that we think you need, we want to be the best solution that you choose to use. And we kind of share that value. So just to kind of set the stage a little bit, what I've deployed here is a RKE cluster. It's a 3-node cluster. And all I'm going to show is the general ease of deploying our Ingress controller inside Rancher's RKE cluster. Now I'm going to go through a user interface, and as was referenced earlier, user interfaces show better. However, this is all done using Rancher charts, which essentially are modified Helm charts. In this case, Helm 3. Any of this could be deployed using automation tools, whether that's a Terraform provider for Helm or a Pulumi implementation using their Helm provider. Any of that could be automated through those tool sets as well as through the CLI. So to get started, I'm just going to go ahead and jump into the cluster. We'll go into the default namespace. I've already deployed Grafana and Prometheus to kind of show, once we've deployed the Ingress controller, how we can pull metrics from the Ingress controller to show us things like what is the current health of the ingress controller? What does our traffic state look like? What are our upstream servers looking like? Just to give a glimpse into some of the visibility that we make available as part of our partnership with Grafana. So the first thing we want to do is go ahead and launch the catalog. We are a partner, a licensed partner with Rancher. So to deploy the ingress controller, I'm going to be using this user interface. There's a number of different versions we can install from our latest all the way through our current one. What I'm going to do is just going to go ahead and deploy this from an internal repository that I've got provisioned as part of this infrastructure. We'll go ahead and leave the default namespace as ingress, and then we're going to go down here. We're going to leave our install kind as deployment. We're not going to be using the default image. We're going to be using that NGINX Plus image that I've already created and pushed out to my Docker repo, my private repo. To get that, I'm just going to go up and visit my cheat sheet here, grab this guy right here, and then we'll drop it right into this spot to give us our location. And then that's pretty much all we need to do to set this up. So basically I've said, I'm going to make a deployment. It's not going to be default image. We're going to use the plus image. This is where our Docker repo lives. It's worth noting that if you choose to use AppRotect, which we've talked about multiple times in this through the course of this webinar, it's very easy to do. In the same repo, you would have a compiled version of NGINX that has AppRotect added, and then you just set this flag to true, and you now have essentially a app protector built directly into your ingress controller. All the rest of this can remain default. I'm going to go ahead and expose the Prometheus endpoint on 9113. And then to get all this started, we'll just click launch and we'll wait a few minutes. So basically what it's doing now is just going out, grabbing that container, and it's going to set it up on my cluster. And as soon as we get a green light here, we can kind of see that's basically all there is to deploy the ingress. And just to kind of prove that's there, I'm going to go ahead and deploy a real quick test app. So let's go into my demo folder, and that's this guy right here. Grab that README, and I'm just going to steal my command line options here. So I'm going to go ahead and just do a standard deployment. So we'll grab this, pop that guy in there. We're going to set up my deployment. Then we're going to go ahead and set up a service for that deployment. And this is just a basic web application. Paste that. And then we'll grab, then we're going to, in the last step, we're going to go ahead and create the ingress resource for that. So real quick, pop that guy in there, and that's it. So now we have a deployed web application. To kind of show what that looks like, we'll do a kube ctl get all. Let's just do get pods -- all - namespaces. And we'll just take a look at everything we've got in here. So we've got our Prometheus exporter. NGINX is running. I'm using MetalLB to offer IPs within the cluster. And then finally, we have our Rancher demo that's set up and running. So that's really all there is to it to get that up and running. And then we'll take a look at what that looks like inside the Rancher cluster. So again, we're going to go into the default namespace. You can see our Rancher demo is currently there. This is our load balancing resource. And then if we go ahead and grab this link and then get it started, you can kind of see what we're doing here is we've got 3 replica sets deployed. Each of those is set to serve a different container at a different time. And then if we want to, because we've gone ahead and deployed that Prometheus endpoint, we can also take a look at what that looks like in Grafana. So I went ahead and implemented a dashboard earlier just to kind of see what's going on inside the cluster. We won't have a great deal of traffic because we just stood it up, but as you can see, we've got a successful reload, which means our ingress controller is active. These are some previous reloads that we have. The number of ingresses that we have deployed is 1. And then if we scroll down here, we can see what our upstream servers look like And we have 3 of those at each of the replica sets. So if we were to kind of scale that, the number of replicas up, which is very easy to do with inside the Rancher Manager, you can basically go into the workload and then scale this guy up to, let's go ahead and do it this way. Go back one. And then we'll just add a few more pods, scale that guy up to 7. And then you'll see that reflected in the Ingress controller at some point in time here in a few seconds. But and we can monitor each of those. And what I'm doing is I'm monitoring my 400 and 500 errors, as well as all the 2s and 3s, just to see what my error rate and my success rate are. Now, we have a vast majority of metrics that are exposed via Prometheus. So this is just kind of a starter dashboard to get people some level of visibility into the cluster. And then as they understand more about what they want to see, or if they want to create more complex metric sets, or if you want to do P96 or P99, all of the elements are exposed in our metrics endpoint to be able to do so. And that's basically it, just to kind of show the ease of use. And it's worth noting that Rancher is one of our partners. We strive to make sure that we have the same relative level ease of use across the board. So for instance, if you're starting off with open source, our open source, the upgrade to it is a straight over the top. You can literally do an upgrade, a Helm upgrade, to just move from our open source version straight to the Plus version if you need the additional feature set and some of the things that Allen talked about. And with that, I'm going to go ahead and turn it back over to Allen.
So as a quick recap, I mean, the net of our presentation of the session is that Kubernetes doesn't have to be that hard, and we understand that there is a large and vast number of different technologies and tooling that's readily available. But in order to get your Kubernetes deployments production ready, these 3 things have been top of mind for many of the organizations and folks that we've talked to, where security, visibility, and scalability has been one of the biggest challenges in deploying Kubernetes into production, where NGINX Ingress Controller and NGINX Plus Ingress Controller can certainly help with this. And as Dylan mentioned earlier, being able to have an agnostic deployment model where, regardless of where your Kubernetes apps are being deployed, being able to have that consistent traffic management, being able to have that security, that consistent visibility and scalability is huge. And then, of course, all of the associated performance gains and reduced costs that come with not using cloud native tooling or tooling that's different per environment is of tremendous value.
A question about deploying NGINX into some of these managed services. So you've shown us Rancher, which is used a lot for kind of private clouds, or I'm somewhere between building my own and running a service. So I can understand deploying NGINX because I'm rolling my own and being quite opinionated about how I want to do things. But if I'm just buying a service to have Kubernetes as a service, like something like EKS or AKS, how does NGINX fit in there?
So I'll take that question. So the answer is it fits in exactly the same way. We have the same version of the Ingress controller that I showed you on Rancher available in EKS as an Ingress controller. You can deploy that from the marketplace. We have it available on Red Hat OpenShift, can be deployed as an operator. It's available in AKS if you want to deploy it as Ingress controller using their version of Kubernetes. In fact, it doesn't really matter, and especially with the adjunct of something like Rancher, where you want to deploy it, with the exception of a very small amount of Kubernetes instances. You can both manage through Rancher or outside of Rancher and deploy us into that cluster, because in addition to being built into the Rancher catalog and all the other various offerings that we have, we also have just a base Helm 3 chart out. If you decide, if you're like some of there's a handful of customers that just wanted to build everything on their own, and they want to put our ingress controller in their version of base Kubernetes. We have published Helm 3 charts and that will allow you to do that. Basically, I mean, not to sound too contrite, but wherever you put a K8s cluster or a K3s cluster or whatever Kubernetes derivation you want, we have the ability to deploy into that cluster. Even edge cases where you wouldn't think it's possible, we can still do it there as well, because we're not built as a reliant technology on any one of these platforms. We're built to be plugged into all of them at your leisure. And that open, your technology, your way, wherever you want to deploy it, whether that's in production, not in production, dev test, whether you're, you're just doing, unit tests or anything like that, we have that capability to plug straight in there. So.
Okay, so this is customers who aren't satisfied with whatever the default option is in something that they've picked, say it's EKS, and they've decided that actually I want the NGINX controller for some reason, and you're saying that the value add for, well, the additional bonus that you can get is that you have all of these other bits and pieces that NGINX can do. So if you've got the Ingress controller and you decide, well, actually, I want to have web application firewall, or I want something else running in containers or something like that, they can then work together as an ecosystem, and I can do that anywhere. So if you, let's say you went with EKS and went, you know what, I don't actually want to do that anymore, or I'm running one thing on premises for some reason, and I'm running other stuff in a cloud service, I can have NGINX everywhere, and it'll work basically the same.
Yeah, and I like to think of it, there's this commercial a while back where they talked about and right, and as the choice, and I think that's the key factor. You don't have to use us for everything. You could use us for a few things, or you could use us for everything, or but I will say this: we are the only ingress controller in existence that will offer you web application firewall at the ingress level. No one else does that. And in addition to that, there's a whole bunch of problems that we've already solved. And one of the things that Alan didn't touch on previously is the default Kubernetes option is the open source community driven version of NGINX, which is fantastic for building a dev test environment. But what we often find people run into is when you start moving to production, it's not built for the level of scale that a lot of people want out of that have come to rely on NGINX for, and that they really want out of NGINX. One of the key factors is that the community version was built with Lua, which is a relatively slow code base to use. Ours is actually natively compiled C++, which doesn't get much faster than natively compiled C. In addition to that, we've also solved things like the upstream servers and some of the routing problems, some of the problems that the community is working on right now, like the gateway solution. And we're in talks with them to try to bring some of that to the community as well, have already been solved inside NGINX Plus. We're a slight step ahead of where community and some of the other providers are. So.